Hello, everyone. Welcome to Space Club, your monthly audiovisual learning broadcast. My name is Danny Bednar, part-time assistant professor in the Department of Geography and the Environment at Western University. With me, as always, is Dr. Tanya Harrison of Mars and of Earth, and online Dr. Phil Stuke, professor emeritus from Western University, from the same Department of Geography and the Environment. And this month we are talking about what's up in the solar system in 2026. So we do this pretty much every year. If those of you who are my students who are watching this in early 2026, forgive the festive decorations. It's now January and festivity has left you and we're just in the doldrums of winter. For those of you watching this in December, happy holidays. Anything before we get going? Probably not.
No. This is always my favorite presentation of the year, so I'm excited.
All right, let's fire up the old PowerPoint machine.
Okay.
And get going. Take it away, Phil.
Okay, well, so what's up in the solar system in 2026? There's quite a lot up in the solar system in this coming year, but admittedly not quite everybody in my little montage there will get visited. But there's plenty happening. So let's move on to the next slide.
Hold on. There we go.
Woohoo. Yeah, and we'll start with the moon. That picture is from one of the Intuitive Machines flights in the last couple of years, and they'll have another one this coming year. Their last two were not quite as successful as they could have been, in that they could kind of they could communicate after they landed, but they had fallen over and they couldn't do things properly. So we're hoping that they will get it right this time and have a fully successful landing mission. Let's move to the next slide. And of course, I guess the highlight in many respects has to be Artemis 2, which is supposed to happen early in 2026, anytime between February and April. We don't have a specific launch date yet, but sometime in this early part of the year. And this is the first time that human beings will have been to the moon, although they're not landing, but to the vicinity of the moon, since way back in the early 1970s, more than 50 years. So, long time. There are the four astronauts, including Canada's own Jeremy Hansen there, who was the one right in the middle.
Sorry.
Oh, no. And this diagram just shows something about what they will do. After launching, they make a big elliptical orbit of the Earth while they check out all the systems on the spacecraft to make sure that everything is ready, everything is operating properly. They also do some things that they call proximity operations, where they will they'll separate from the upper stage that launched them and then fly around and observe it from different directions, practicing basically for some of the things that they'll have to do in future Artemis missions, when they will be docking with a lander in lunar orbit, or docking with a small space station called the Gateway in lunar orbit. So they're practicing for some of that. And also, although I don't think it says anything about it here, no, it doesn't, they'll also be launching 4 little CubeSats. Actually, the astronauts don't do it. They're on the upper stage, and they'll be launched during that stage of the flight. And then that upper stage will burn up in the atmosphere. And the crew will then leave the Earth on a long cruise out to the moon, several days out to the moon. They're not going to land, they're not going to go into orbit, but they're going to loop around the far side of the moon and then come back and back into the Pacific Ocean off the coast of California.
But this is a quite different trajectory from the Apollo missions, isn't it?
It's quite different from most of them, except for Apollo 13, which sort of did something similar. Apollo 13 couldn't land and had to loop around somewhat like this does.
Okay.
and back into the Pacific Ocean. So it's but it's not really like exactly what Apollo did, because all the Apollo missions which landed went into lunar orbit. They orbited the moon for multiple times, during which time two of the crew could go down to the surface and back.
Right. And 10 went into orbit, correct?
Yes, Apollo 8 and Apollo 10 also went into orbit, but didn't land. Yeah, I should have said that. Okay.
It's
So anyway, that would be a highlight. Now, when they fly around the back of the moon, they're at quite high altitude. They're at high enough altitude that they will be further away from Earth than any human beings have ever been. The previous record holders were the Apollo 13 crew, but these will be several thousand kilometers further away.
So Jeremy can be a record holder for Canada.
Yeah, that's right.
I mean, one of the astronauts, whoever's sitting furthest from the moon.
Now, Jeremy's a bit taller than the others, so I reckon that he might be a bit further away.
I have no comments about the future of this, because I can't. But yes, it's the Apollo 8 of Artemis in some ways and shape.
Right.
Did it also do this elliptical thing around Earth first?
Well,
no, not in the same way. No.
Oh, okay, that's the part that I thought was different. Yeah.
Yeah.
I'm just thinking of the old Apollo visual, which is also a figure 8, but it is not as elliptical. I also assume that visual, mostly made for TV, was not perfectly accurate, so I don't know how elliptical.
Yeah, well, that's true. It's not to scale.
Right. Well, this, yeah, but the in-orbit maneuvers around Earth are very Apollo 7, Apollo 9, and 8 didn't really do any maneuvers. It was just go out there and come back.
No, Apollo 8 also entered orbit.
Oh,
So
right, but it
they
didn't.
did.
Oh, yes, it undocked the. No, it didn't. It didn't undock.
It didn't. Apollo 8 didn't have a lunar module, but
Right,
it did
yes.
go into
10
orbit.
10 did various docking and undockings in lunar orbit. 7 and 9 did it at Earth orbit.
Right. So Apollo 8 didn't do any of that in lunar orbit, but Apollo 10 did.
Yes.
Apollo 10 had a lunar module.
I just said that, Phil.
Yes, that's right. So that's right. That's what they did.
Okay. This is the rocket, not the scale.
They flew that lunar module. They flew the lunar module down until they were only 15 kilometers above the Apollo 11 landing site to test all the navigation and communications between the two spacecraft and the ability to redock and everything.
They should have just taken it right down.
I know, so close and yet so far.
Anything else on this? There's a lot here.
No, I think that'll probably do it.
Okay.
Let's go to the next one. Whoa, then we have this. So now this might fly even a little bit before Artemis 2, but we don't have a firm launch date for it yet. This is a Blue Moon cargo lander built by Jeff Bezos, who is that fellow standing there. Well, I guess he didn't actually build it, but he did pay for it. So yes, so that guy is Jeff Bezos. So every time you buy something from Amazon, you're contributing to this.
That's not all you're contributing to, but
No, that's right. Okay, so anyway, so this is the first flight of a new cargo lander. It will. It's not really carrying any cargo here except a couple of NASA experiments. One of them's looking at the impact of the rocket exhaust plume on the surface and the way it blows stuff away and everything. They're going to look at that. This is just a test flight, and then in future flights, they'll actually carry cargo. This is the kind of thing that can carry about 3 tons of cargo. So it's a lot bigger than the other recent landers that we've had, like the Firefly lander that landed last year, can only carry about 100 kilograms of cargo. This is 3 tons. So this is the kind of lander that would be doing things like taking supplies and equipment to an Artemis landing site before the crew get there. They could deliver a rover, they could deliver science equipment, stuff like that. and have it all pre-deployed and ready for the astronauts when the astronauts arrive. It's designed for that kind of purpose. So that's, yeah, and somewhere near the South Pole. Okay, let's go to, right, so then we do come to another Firefly mission. So this is a company called Firefly that had a very successful landing early last year. And there's a lot of tremendous visuals that came from that, videos of the landing and all sorts of surface operations and so on. And this one is carrying a radio astronomy experiment as well as a few other things, and it will land on the far side. That means that it has to have a relay satellite, and they're carrying their own relay satellite. When it's not relaying, it will be using a high-resolution camera to image the surface. They're also carrying a rover from the United Arab Emirates, and the UAE had a rover on a Japanese commercial lander a couple of years ago, and it crashed. So they're flying again on this one, and hoping that they'll have a successful rover mission from it.
I believe there was Canadian involvement on that one, was there not?
Yeah,
There was on the previous one, but I don't know if there is on this one. I don't know if there's. They were, for the previous one, they were using Canadian software from Mission Control in Ottawa.
Never heard of them. This may also be a no comment situation. This is the problem
Yes, I know.
with working in space.
That's right. Yes. So we will have to see.
Yeah.
When it gets to the moon, we will know whether or not there's Canadian software on it.
Yes.
Okay, so here's another lander. So that Firefly lander is somewhere in the middle of the year, and so is this one, perhaps in the second half of the year. This is the Intuitive Machines lander, the one that has had a couple of sort of only very partially successful landings. And they'll be hoping for a more successful landing this time. The other two went near the South Pole. This one is going to a place near the equator, a very peculiar spot called Reiner Gamma, which is that funny bright elliptical shape right where it says Lunar Vertex Landing Site. That strange kind of bright elliptical thing is called a swirl. And it's there are quite a lot of them on the moon. This is the most well-known of them. There's more of it kind of going up to the right there, yeah. There's kind of a tail that goes up through there.
Okay.
So the whole purpose of this mission is to find out what causes this swirl. And we also know that it's a magnetic anomaly site. There's a strong magnetic field under that spot. Most of the moon doesn't have a magnetic field to speak of, but this little spot has quite a strong field, and somehow it's producing this bright marking on the surface, perhaps by altering the way that the charged particles from the sun hit the surface. They don't really know how that happens. So this mission will land a rover, which you could just kind of see in the little cutout picture at top. The rover has a magnetometer, it has a microscopic camera, which is Canadian, which will image the surface in stereo at very high resolution right in front of the rover, looking at the fine structure of the regolith to see if they can figure out why this bright marking is being created. And it will drive across the sort of dark lane that you can see in the middle of that landing site, like sort of just above the yellow dot of the landing site there's a dark line, and they will land on one side of it and drive across it, looking at the changes in the magnetic field, subsurface structure, and the texture of the regolith, the surface material. Yeah. So
how did we know it's when did the magnetic anomaly? Is that from Grail data? I don't know if Grail would...
No, it was from Lunar Prospector, an early remote sensing mission of the new era, post-Apollo. didn't know
Right.
about this for Apollo.
From
But,
the dark days of the 90s.
That's right. Yeah. Okay, so there's another lander. And here's another one. So we've got quite a few lunar landers. This one is from Astrobotic. Astrobotic had a rather disastrous flight a couple of years ago with a different spacecraft called Peregrine, which was supposed to land, and it suffered serious propulsion problems almost immediately after launch. Couldn't go anywhere. Basically just looped out towards the distance of the moon and then back and burned up in the Earth's atmosphere. They did get to test some of the equipment that they were carrying, kind of thing, but like measuring magnetic fields and things like that. But they couldn't really do what they intended to do on the surface of the moon. But the same company flying a different lander this time is going to a place near the South Pole carrying a rover. It's not the rover that they were originally supposed to carry. They were going to carry a rover called Viper, a NASA rover, which would be exploring ice or other volatile materials, frozen stuff in the lunar surface near the pole. But NASA got spooked by the failure of the first lander and decided that they would hold back their rover from this mission. So this becomes a test flight instead of an actual serious delivery of important scientific hardware. But they were able to replace it with another rover, which is a test for a future bigger rover that would carry people. So NASA is contracting out the construction of crew carrying rovers for Artemis. They have 3 different companies developing rovers for that purpose, and this is testing hardware for one of those companies. It's a little rover called Flip. I can't remember what that stands for now, but it will roll off of the lander and experiment with a lot of rover systems, with software, with wheels, with steering, communications, and so on, testing for this other rover.
If you name a rover Flip, it should be able to operate on either side. Like that's when there's rovers that if they get flipped over,
you would hope so, but I don't. I think if it landed upside down, they would be having a very bad day.
Well, if the lander's upside down, you're screwed. But if the rover has the ability to kind of go up dangerous terrain, and if it happens to fall over, it's got a little flip mechanism, like in BattleBots.
Yeah.
If only that were true. But
Well,
it's not.
I'm sure some of these BattleBots kids are now working at these space companies.
Well, maybe that will happen at some point.
Mechanism.
On this one, we can say there is Canadian software involvement. On
no, yes, actually, because apart from that big rover, there's also a second rover, Astrobotic's own little rover called Cube Rover, which, as Tanya is hinting there, is about the size of a microwave oven.
It's like even tinier than Pathfinder, Sojourner was on Pathfinder.
Yeah. Sorry. So anyway, and we do know that does have Canadian software on it.
Well, that one's interesting because, you can kind of see in the graphic here, the bigger rover is going to deploy like most of the other rovers we're used to. You drive down a ramp, but the small rover is going to come down on cables like a marionette, and then the cables need to disconnect for it to drive away.
So on the bottom here. Well,
that's good. I haven't seen that.
I think it's suspended off the back.
Yeah.
If I recall correctly.
So hopefully it doesn't get all jumped up from kickback from the descent.
Yeah, it's gonna be interesting. I shouldn't say more than that.
Yeah. Incidentally, you can see the deployment ramp for the bigger rover there, and it doesn't go all the way to the ground. The rover comes off that ramp with its wheels tethered, and as it rolls, they gradually kind of unroll the tether and then they'll cut it free. But there isn't actually a ramp all the way to the ground.
No, it's like a jump. Like they fall. But if they're tethered. Okay.
All right. So there's yet another lunar lander. Let's see what else is happening. No. Okay. So I think this is going to be one of the most dramatic missions of the entire year. Chang'e 7.
So cute.
Yes, a hopper. So this is Chang'e 7. It will be China's 5th landing mission, and they've been completely successful with every other landing mission, so I hope they will be with this one. The graphic here shows in the top left a relay satellite, which is already on the station, waiting to relay data from this lander, which will go to the South Pole. There's a lander, there's an orbiter as well. The lander touches down and it releases its own rover, which you can just see kind of driving off from the lander in the upper right part there.
Solar panels.
Yeah, that's right. And they're landing near the South Pole, so they need vertical solar panels to get the horizontal sunlight. And then there's also this hopping vehicle, which, I don't know, they kind of make it look like it ought to be spring-loaded or something, the way they've done that, but it's not. It's little thrusters. And so it will jump up into the air and translate over to the side and drop down again, and do that multiple times, hopping around, including flying over and into a permanently shaded area and then jumping out of it, but with time to do some analysis. Now, this is going to a spot that is so close to the South Pole that it experiences a considerably longer period of sunlight than most parts of the moon. Normally you get 2 weeks of sunlight and 2 weeks of darkness, but at the poles there are a few spots which can have multiple months of continuous sunlight, and that will happen here, where they're going to have at least 3 months of continuous sunlight. They say that the lander is designed to last for 8 years, and they have good reason to think that it will, because the previous landers for Chang'e 3 and 4 have lasted for many years. The lander's supposed to last for a long time. I don't know that the rover can last that long, although possibly it can, I don't know. And the hopper certainly won't, because it's going to be constrained by the amount of fuel it can carry, which won't be very much. So it would have a shorter lifetime. But the rover could last quite a long time, possibly at least 3 months, possibly several years.
So this thing comes apart. You got the orbiter and the rover, or orbiter and lander standard.
Yeah.
Then the lander's got, presumably just tucked away somewhere, but
yeah,
and the hopper on top, presumably as well.
I think
at the bottom.
Yes, the previous rover missions from China had the rover on top, and it rolled out onto a ramp, which was then lowered by a sort of elevator system down to the ground. And I imagine this will be something similar.
Yeah.
So probably the lander and the hopper are both on top. The rover and the hopper are both on top, but I don't know exactly how that will work.
Cool.
Anyway, it could be quite a dramatic mission. All right, and since we're talking about China, I ought to mention Chang'e 4, a rover that is operating still after 6 years on the moon. It's moving very, very slowly at the moment. Sometimes not moving at all from month to month, and then some months moving 5 or 10 meters. It's very constrained in what it can do, and I don't know what the reason for that is.
It's on the far side of the moon, Phil.
It is on. Oh yeah, it's on. It's on the far side of the moon. That must be it. Although they were doing a lot better earlier in the mission, and right now they're not really saying a great deal about it. Although they do publish lists of drive details.
You must be getting traversed from somewhere.
Yeah, so they started at the lower right of that star, and they're moving up in the other direction. They've actually gone a little further than that line shows. I hadn't updated it quite since I made it. But the only way we have right now to monitor where the rover is when LRO takes an image of it, and the two images below there show it in the little rover in two different spots.
Tiniest little speck.
Yeah, that's a tiny little dark spot just at the off the arrow. Yeah, that's right. And if you see where that is relative to a sort of triangular shaped crater,
Yeah,
it's moved a bit.
this and this.
Yeah, that's right. Yeah.
So
So that was a move over the course of 6
half an
months.
inch.
Yeah, over 6 months there, it moved maybe
Half an inch. Right.
8 meters. I would
Oh,
say.
okay.
Yeah, something like that. But I don't know. There's definitely something wrong with the rover, and we just don't really know exactly what's going on with it.
How far approximately has the total traverse been?
It's about 1.7 or 1.8 kilometers.
Wow.
So it's not long distance, but they stop and make measurements very frequently. So they've got a lot of measurements along the way with ground penetrating radar, and they have a really nice cross section through the regolith from that. And there have been a lot of papers about the evolution of the subsurface from that. And then they've got infrared spectrometer for composition as well.
It's only got 9 kilometers to go to catch Lunacar.
Check back 20 years.
Okay, all right. So let's move on.
Ooh.
And yeah, so that's the moon, right? And there's quite a lot happening at the moon. But now let's have a look across the rest of the solar system. Here's Mercury. And a spacecraft called Bepi Colombo, a European, it's a joint European and Japanese mission. It has been flying for about 6 years, and it will finally, actually nearly 8 years, it will finally get into orbit around Mercury late in 2026. This picture was taken during a flyby of Mercury, and you might say, well, if you're flying past Mercury, why not go into orbit then? But the trouble is that they're flying past at very high velocity, and they've only got so much rocket power to get into orbit, so they couldn't go into orbit on these earlier occasions. But over multiple flybys of Mercury, they massage the orbit until it changes until it's quite similar to Mercury's orbit around the Sun. And that means that the approach is very slow, and you don't have to brake very much to get into orbit. So that's what they're doing. So that will be a multi-year mission in Mercury orbit once they get going, building on what a previous spacecraft called Messenger did, and should be an interesting look at a not very well understood planet.
How long was Messenger in orbit?
Oh, getting on for 3 years, I think.
Yeah, 3-4 years.
Yeah.
I hope we get a good, 8 years is a long time to get into orbit, obviously.
Yes, that's true.
I hope we get, I hope the trade-off is in exchange for that. We get a good number of orbits, years.
Yes, I would hope so.
Yeah, because that's a tough sell in this economy. 8 years from now we'll be at this planet.
It was crazy that it took longer to get to Mercury than it took for Juno to get to Jupiter.
Yeah, that's right.
So.
Okay. So anyway, that takes care of Mercury. Here's Venus. There's going to be a Venus mission sometime in the first half of the year. We don't have an exact time, and it's called the Venus Life Finder. I'll say something about life on Venus in the next slide. First, I want to say this is the first purely commercial planetary mission built by, paid for by, flown by, operated by Rocket Lab, a New Zealand rocket company. They started out building a sort of a little upper stage, kick stage thing so that when they launch a satellite, they can push it to wherever it needs to go. And then they adapted that to become a little interplanetary spacecraft. So on this mission, it's not pushing something else where it needs to go. It's doing it all itself. So it's going to Venus, and it will drop a probe into the atmosphere. Now, what's all this about life on Venus? Let's have a look at the next slide.
I have a feeling we'll talk about this.
Oh, it's the same slide except the text is different. There we go. No, that's fine.
Wait, there we go.
What's that? There's life on Venus. Over the last few years, people have detected a trace gas called phosphine in the atmosphere of Venus. And on Earth, that is usually produced by microbes. It doesn't mean it has to be, but it has that association on Earth. So when it was discovered by remote observation, telescopic spectra, when it was discovered in the atmosphere of Venus, some people said, oh, maybe that means there's life, and it can't be on the surface, which is just ridiculously hot. But it could be floating in the upper atmosphere. So the hypothesis is that there might be microbes floating in the atmosphere above the clouds. I mean, I say microbes, I mean maybe they're bacteria or something like that. Some kind of little living thing. And I suppose, I haven't looked at the details of this, but there are going to be bacteria and maybe other little things floating around in the upper atmosphere of Earth. I don't know how high up they go. I've never really thought to look it up, but I suppose I should. But they could float pretty high up in the atmosphere. And so the idea here is that they might do that in the upper parts of Venus's atmosphere. I don't know if that's really true. This is testing a hypothesis. I kind of doubt it myself, but you never know. So you've got to go and look at it. And that's what this spacecraft will do. Drops a probe into the atmosphere, which just has a relatively short time to do some very detailed analysis on what it finds there. Doesn't have a lot of time, but it will do that and transmit the data back.
It's the same old story, right? We talked about this a couple episodes ago. Like, it's always, we found this thing that can either happen biotically or abiotically. And obviously, if you're part of the team that found it, you're like, oh, well, we got to point out that it could be abiotic or biotic. We want to get the press. Yeah, it'll be interesting to see. I was also like, I think we talked about this before in the past too, where I asked you, like, what is the business model of this? Like, but I think, like,
as far as I can tell, there isn't a business model. As far as I can tell,
right.
This is just Rocket Lab is making enough money from its launch vehicle operations that it can pay for it itself. But if they prove that their little spacecraft is capable of doing missions like this, then they could conceivably sell that to anybody who wants it.
Not the worst promotional campaign in the world, I guess.
Yeah, I think it's smart. I mean, they also, this kind of got buried since Blue Origin launched the mission, but the Escapade satellites for Mars that launched very recently were built by Rocket Lab.
Yes.
And so I think Peter Beck, the founder and CEO, like, has a vested interest in planetary science. He's more of a Venus person than a Mars person, at least if you asked him back in the day.
We need more of those.
Yeah, so I think part of this is, pet project-esque for him, but I think they do genuinely want to move into sort of commercial planetary stuff because, NASA's been doing all these commercial lunar missions like you just went through. They've started putting out feelers for Mars to replace some of the capabilities of aging satellites there because right now there are no slated NASA missions to Mars.
Yeah, that's right.
So they're like, hey, commercial sector, what could you do for us? And Rocket Lab has put together some ideas. There's a couple other companies that have tossed their hats into the ring as well. So it'll be interesting to see what happens. I think a lot of it will rest on how successful are these upcoming commercial lunar missions, since they have not been wildly successful yet.
You make a good point about, like, there's a business case to be made for just providing the architecture. Even if there were landers and rovers that are still publicly funded, the architecture to communicate and relay information back could be commercial. Like, there could be a business case built around that.
Yeah.
And then, obviously, if your company provides, I don't think just based on the experiment, it would be a single probe hitting one tiny part of a big planet. It may not be definitive evidence, but if you contribute to, like, pretty important evidence towards life on another planet as a company, it's probably worth the gamble if you're already kind of building the materials anyways.
Yeah. All right, let's move on. Oh, now we can come to Mars, and there's plenty happening at Mars these days. I think I counted correctly that there are 7 orbiters working there. That would include the Chinese orbiter Tianwen-1, which is still operating. I think I've got that right.
Can we name them? There's Tianwen, Hope. Is that what it's called?
Yeah, Hope. Right.
Isn't there one that's just called Mom? Mars orbiting?
That's not operating anymore.
Okay. So then what about the old timers?
So then you've got Odyssey.
Global Surveyors?
No, not Global Surveyors.
That died 20 years ago.
Oh, maybe I'm confusing it.
Mars Reconnaissance Orbiter, I think that's what I'm thinking of.
Yeah, so Odyssey, MRO, Maven, and then Europe's Trace Gas Orbiter and Mars Express.
Express, I was going to say. Maybe I think I confuse Express and Global Surveyor.
I think that's
Trace TGC.
So anyway, they're all continuing to operate, and I'm not going to say anything about them here. And I just mentioned 2 more were launched a few days ago there. That's Escapade, of course, which still gets mentioned. But the pictures from the James Webb Space Telescope, and of course it's worth pointing out that Hubble and James Webb can also give really good Mars data sets. They look at Mars and other planets from time to time. Now let's go on and have a look at what else is happening with
Famously,
Mars.
we learned that when we did the Mars draft, and Raymond, with his leftover currency, drafted Hubble because it can technically image Mars.
All right, so here's one of the 2 operating rovers, the Curiosity rover, which landed in 2012. Seems like an awfully long time ago now. They've traveled 36 kilometers across very interesting terrain. For the first half of that route that you can see there, they were basically on the plains on the floor of the big crater called Gale. And they had to drive to a place where they could get across a patch of dark sand dunes. They can't really drive on the sand dunes, so they had to get to a place where there were gaps and they could sneak through. And once they got past that, they're coming up the slope of this mountain and passing through material of different composition at each level. So there's a lot of interesting geology, and the geology is tied into changes in climate in the past, and that's what they're interested in. So we can see where they are now, at the lower end of that current location. And let's take a look at the next slide, and we'll see that in more detail. This is what the area looks like. It's a rather funny looking material called boxwork, which consists of a whole bunch of ridges. So those things are ridges. Sometimes it's hard to tell if it's a ridge or a crack in the ground, right? A depression, but they're ridges, and they intersect at all sorts of angles. There's lots of them running in different directions there. People generally think that what must have happened here is that the surrounding rock had cracks in it, which filled with something else. That solidified and was harder than the surrounding rock. So now, when it erodes, that stuff that is filling in the cracks is harder than the surroundings, and it stays standing above the surface while the rest erodes away. So the rover's been picking its way through this very complicated terrain, having a quick kind of survey of what it's like, and now they've gone back so that they can look at some of the most interesting areas, and they're in the process of analyzing samples in this area.
Aggressive turn back. I feel like I haven't. Did it re-follow its exact path back?
Oh yeah, yes. The thing is, the surface is so complicated and irregular that if you can find a way through it, and then you have to go back, chances are you are going to go the same way back, because it's a very irregular surface with all these ridges cutting across it. So they followed the track back almost exactly.
I feel like they haven't done that a ton with like I feel like it's pretty unidirectional with the rovers for the most part.
For the most part, but there are places where they backtrack.
Retrace.
Yeah.
Cool.
And especially if they follow this strategy of doing a quick survey and then backtracking to get to the most interesting things along that survey. And there are several places where I think all rovers have done that from time to time.
Take a glance at all your surroundings, and then once you realize the best things, go back to them.
So now this is the rover Curiosity. It's the rover that analyzes the surface material where it is. It's not collecting samples that could be brought back to Earth. It's just analyzing stuff where it is. So they kind of drill away at the surface to make a little pile of powder and then dump that into the analytical instruments on the rover. Sam and Chemin.
Sam what?
Chemin. Chemistry and mineralogy. Chemin.
Right.
Okay, let's look at the next one. The next one is our other rover, Perseverance. And this is the one that is collecting samples which might eventually be brought back to Earth, although we don't have a specific plan for that yet. Anyway, this shows the way that it's driven. It landed in 2021 and it's already driven further than Curiosity, about 39 kilometers to its current location. You can see where it landed. And it did one of these things where it drove off to look at something and then retraced its steps back to the landing site and then went on. So, yeah, there's another case there. Every little pink dot there is where they've collected a sample. And at this scale, actually, you can't see them. Sometimes there are multiple dots close together there. So they've collected samples in quite a few places. And my little notes on there show the different kinds of material they've looked at. So on the landing site, there are lava flows. The lava flows are covering up what is presumably a sedimentary lake bed, but that's not exposed anymore on the crater floor. But then they get up to this delta where there are lots of sedimentary rocks exposed, so they've collected samples at multiple places along the delta, and then down in a channel on the top at the north side of the delta there, where they carried a little helicopter with them, and it broke down after a bad landing, where that blue marker is.
Lava flow, this general thing, all right?
The stuff that's not on the delta.
Oh,
yeah. So lava flows on the crater floor.
Okay.
And then the delta is sedimentary.
Yeah.
And after that, on the left-hand side, they're coming up onto the crater rim, and here they're looking at very ancient rocks dug out by this crater, which was probably 4 billion years old at least. So we've suddenly gone from sort of relatively younger rocks, maybe 3 billion years old or so. We don't really know the dates for those things, but to older stuff, 4 billion years old on the crater rim, and that's where they are right now. So they've collected some samples already from up there, and they're going off to look at a whole series of other samples out beyond the crater rim. And ultimately, it appears that they're going to loop back and follow a path back towards the landing site. There were two possibilities. They could either keep on going outside the crater and then deposit all their samples, and a spacecraft would have to land there and pick them up, or they could come back into the crater where there's a superb landing site, very smooth, very flat. It would be really easy to deliver the samples there to any future thing that comes to pick them up, and it looks like that's what they've decided to do. The potential landing sites outside the crater are not as good.
Part of me that wants to see new stuff is like, no, keep driving.
Well, are we thinking they'd go this way, like outside of the?
I think they have to go through the inlet channel because there's not great topography. So
no, there's although you can't see it in this view, there's a lot of sand dunes in these low-lying areas, and these rovers don't do well on sand.
Either way, it's gonna fly past Opportunity at some point. I was just looking it up. It's 45 kilometers distance. sure.
Yeah. Oh, they will easily surpass that.
I think part of this was so it took Curiosity a long time to get from the landing site to Mount Sharp, where the real science was going to happen. And there was a lot of pressure from a political standpoint of, well, we sent this $2.5 billion rover, like, what's it doing? And on the science team, we had to be like, well, we're not there yet. We knew this was going to be what's called the go-to site, and that it was going to take a couple of Earth years to get to the sites of interest. And so I think that weighed really heavily on the minds of folks with Perseverance to be like, okay, we can't dawdle. We'll do the minimum stuff that we can do at the landing site that we need to do to check off the threshold science goals, and then just start booking it so that we get to the delta like as much as we can. And I did not realize they had driven this much. Like, this is so impressive in such a short period of time.
Yeah, it is. The rover can drive a lot further than Curiosity. It has much better auto driving capability. So they sometimes drive in 500 meters or more in a single stretch, just relying on auto navigation, and it's working.
Raymond.
Yeah, there you go. That's right. Okay, let's go to the next slide. There, this is where they are right now, current location. And actually, I have to confess this: as I made this slide, they've actually gone a little bit further, but it shows the basic idea anyway.
My students pay for the best, most current, up-to-date information.
Oh, sorry.
That you do all the work for.
Yeah, so you can see up at the top of that slide where the line comes in from the top of the picture, there's some white patches, and those are rock outcrops, and they're looking for more rock outcrops as they go out. But there's a lot of sort of gravelly surface, really good for driving on, and occasional sand dunes here. And they're kind of driving and looking for good outcrops that they can sample. When they find a really interesting outcrop, they'll sample it. Okay, so that's still operating. Here's the Escapade, which we mentioned, the little Rocket Lab spacecraft, which were launched just on the 13th of November, so only a few weeks ago. But this is not one of those occasional periods, like every 2 years, when you can actually get to Mars. So Escapade is actually loitering in a loose orbit around the Sun-Earth L2 point for a year. And then at the appropriate time, they'll do an Earth flyby for a gravity assist and head out to Mars. So, yeah, that's what's happening there.
So for my students, this may or may not be covered depending on which lectures I use in a given year, but the L2 Lagrange point 2, it's essentially, I know I said gravity well one time, technically a well, but there's in any two-body system, there's 5 points of kind of gravitational stability, for lack of a better word, where you can kind of hang out without using a lot of fuel. And a lot of spacecraft use that. Some space telescopes even sit in those permanently. And yeah, spacecraft make use of those if they're waiting for an alignment or something. Yeah,
they've used more and more all the time these days. The James Webb Space Telescope is one of those in the Earth-Sun system. Okay, let's move on. Here's something else which is going to be a tremendously exciting mission, I think, launching quite late in 2026. MMX, Mars Moons Exploration. It's a Japanese mission, and Japanese space program doesn't have a huge amount of money, nothing even approaching what NASA has. But so they've chosen to do really cleverly targeted missions that other people are not doing. So, for instance, they were the first to collect a sample from from an asteroid with their Hayabusa spacecraft, and then they did it again with Hayabusa 2. And admittedly,
we got there.
At that point, there was a NASA mission to do the same kind of thing with a different asteroid, but they were doing it first. And now they're doing it the same kind of thing with one of the moons of Mars, Phobos. a little moon of Mars. There's a picture of it there, a kind of irregularly shaped lump orbiting Mars.
Perfectly fine shape.
Yeah, just don't make any more craters in it.
Yeah, it's not as smooth as its brother.
No, that's right. There is another moon called Deimos, and this orbiter will look at Deimos but not land on it. But it will land on Phobos. It has a little German rover that will drive around. It will analyze the surface of Phobos. It will collect a sample and bring that back to Earth. So it's going to take about four years or so before you get the sample back. It's quite a long time. But still, that will be a really interesting mission. And it launches late in 2026. So it will really be 2027, 28, 29, I guess, when sort of the more interesting things are happening at Mars in that mission.
I was curious how their budget compared to Canada for the stuff they're doing. It's low compared to NASA, but still much more than we have. It's about 1.5 billion US dollars.
Oh.
So I was like, wait, could we be doing this? No, we don't have that much money.
No. Oh, well.
And that JAXA DLR, the German Space Agency partnership, has been really, like, they were involved with the two Hayabusa missions, and
yes, they were.
Be a very helpful, fruitful partnership in terms of these little missions to collect samples.
Yeah, that's right. They dropped a little hopping rover onto the asteroid that they sampled, Ryugu. Yeah, a German hopping rover called Minerva, I think. Yeah. Okay, here we go. And I should just mention, just thought we'd look at a launch picture there. That's a Falcon Heavy with this spacecraft called Psyche on top of it, which is an asteroid mission. It's on its way to an asteroid called Psyche, a metallic asteroid. Should be an interesting mission when it gets there in a couple of years. But in March 2026, the spacecraft will fly past Mars to get a gravity assist to reach the asteroid. So we'll get some pictures from it probably. I don't know if anything else will happen there, but that will be so they calibrate instruments, so they'll be measuring the magnetic field, taking some pictures, doing some compositional measurements maybe, but it's really designed to calibrate the instruments. So we'll see that coming up in the middle of 2026 anyway.
And the Psyche encounter is 2029 or into the 30s?
28 or 29, I forget exactly which.
Yeah, for some reason 29's in my head, but I don't know why.
Yeah.
Sounds familiar. I don't think it's the 2030s.
Okay, let's move on to the next slide here. So that Psyche mission is an asteroid mission, but we're going to have a really interesting Chinese mission to an asteroid as well in June. This is their Tianwen-2 spacecraft. Tianwen, which means...
That was also Tianwen.
Tianwen-1 was the Mars rover mission. So Tianwen is the generic name for China's planetary exploration program, apart from the moon. That's its own name. So Tianwen-2 here is an asteroid sample return mission. It was launched about half a year ago, in May 2025, and in the middle of 2026 it will arrive at this funny little asteroid here, whose name I would prefer not to have to say. So I'll just call it 469219. It's a Hawaiian name. My Hawaiian is a bit rusty here.
I think it's Kamo'olea, is my guess.
Oh yeah, well that sounds good. Yeah, so I'll let you do it. So anyway, this is a little near-Earth asteroid. It's not just a near-Earth asteroid, because there are lots of them that can come fairly close to Earth. This actually is almost in Earth's orbit, sharing Earth's orbit. It's possible from spectra, the spectra that we can get, that it's a chunk of the moon, that it may be a clod of ejecta that has been thrown off the moon by a big impact. It would spread out around Earth and out along Earth's orbit around the sun, and some of it is accumulated together to make this little asteroid. which has a reflected spectrum like the moon. And I would say that big impacts that could make that happen don't happen these days. Well, very rarely. We better hope they don't happen anyway, because it'd be a big mess if they did. But they happened in the earlier years of the solar system, and they would throw a lot of stuff off the moon. Most of it would fall back onto the moon eventually. It might make multiple orbits around the Earth or even the Sun, but then hit the moon. Quite a lot of it would hit Earth, and people are starting to become a little concerned about exactly what would happen with this, because if you blast stuff off of the moon and it can fall to Earth, it's going to fall right through the geostationary satellite belt and all of these constellations of communication satellites and remote sensing satellites and things that we have right now. And it could be a bad day for some of those satellites. This, I suppose people had thought about this in the past, but it really came to my attention with a very recent study done by Paul Wiegert at Western and other astronomers who predicted that a little newly discovered asteroid has maybe a 5% chance of hitting the moon in about 5 years' time. Chances are that it won't hit the moon, that as they refine the orbit, they'll see that it will miss the moon. But there's this possibility that it will hit the moon. And if it does, it's big enough to blast stuff off, some of which will fall to Earth. And it was their study that highlighted the danger to Earth orbiting satellites. And that, I mean, that's sort of the space station too. So if something does hit the moon,
Not be an issue in 5 years.
well, that's true. It might not be. We'll see. Anyway,
Interesting.
here we are. We're going to get a sample from this little thing from the Chinese mission, and so that will all be happening in the middle of 2026. And
But this
should be
also has
an
implications
interesting
for industrial activities on the moon in the future.
mission. Mhm.
If companies just start blasting open pit mines or something.
Yeah.
Yeah.
So now, I feel like NEOs kind of like 20 years ago with orbital debris. It was a topic, but it was kind of niche and no one was that interested. But now it's a mainstream policy topic and concern and orbital debris and junk. I feel like NEOs, they go up and down in terms of interest. Like there was DART and a few other things. I mean, obviously they're either the most important thing ever, or they're not important at all. They're one of those very unique hazards. But I could see some more interest, especially now if we have more infrastructure near the moon. Now we have two targets to worry about, two impact zones.
Yeah.
As you mentioned, Phil, debris from even relatively moderate impacts. Could be interesting.
Yeah. That's right. Let's move on to the next. Oh, sorry.
Okay, it's time for the next Armageddon type movie to come out.
Yeah,
So that the Republic cares about asteroids again.
That's right. Yeah. Okay, let's move on to the next slide here. Here's another asteroid mission, which hasn't really got a lot of publicity, probably. This is the Hayabusa 2 spacecraft. It collected a sample from an asteroid called Ryugu and brought it back to Earth. Dropped the sample in a little capsule that came through the atmosphere and was picked up. And now we've got those samples. But the spacecraft that did it flew past Earth and is going on to look at a couple of other things. And one of those will be this coming year in July. This little spacecraft will fly past a small asteroid called Torifune. And it'll just be a very quick flyby. It's a small object, a few hundred meters across, but it should be an interesting chance to look at a new object that we haven't seen before.
Did Hayabusa 2 do a gravity assist around the sun so fast that it traveled back in time? You mixed up your dates, but
did I? Oh,
well, launched in 2024 and brought a sample to Earth in 2020. I would be remiss if I pretended I never mixed up dates on this slide.
You are correct. I do seem to have made that mistake.
I look forward to my students who use AI summaries of the YouTube auto-generated text, who will report this exact backwards fact. Not that any
Yes.
students would do
Okay, I did get it backwards. All right, fair enough. Mea culpa.
that. But if you've seen Star Trek 4, you know it's possible that if it went
I don't feel so bad. I don't feel
if you
so
just the right calculations, which
All right.
have to be done by hand for some reason, I can't remember why, and not the computer, but luckily they have Squawk. They whip around the sun at such incredible speeds that they travel back in time, which I think they also do, hold on, Phil, in First Contact. Or is how, no, they jump back in time, but
They go through like a Borg.
yeah, they
transform
just,
onto it.
they hitchhike with the board.
Yeah.
Okay.
Anyways,
Whatever. Okay, now let's look at the next slide. Ooh, got past that one. All right, good. So now, here we have a mission from the European Space Agency called Hera. And it's going to an asteroid called Didymos, which has a little moon called Dimorphos. And this was the asteroid that was visited by the DART mission in according to my calculations, 2022. Although maybe it was 2028, I'm not sure. Anyway, so this was the one where the DART spacecraft smashed into the moon. It had an impactor that smashed into the moon. The spacecraft itself and a couple of little CubeSats observed all of this from a distance, and basically observed what the effect of the impact was, and after that, then astronomers mapping the position of this little moon in its orbit detected a slight change in the velocity of the moon. So they know that impacting the moon changes its velocity, which is what they were trying to test, because this is a test of a dangerous asteroid deflection maneuver. So here, what Hera is going to do is make close observations of the system, much better than DART was able to do, because it was kind of in a hurry to do what it had to do. Hera will orbit the moon, the asteroid, and look at its little moon, look at changes in the moon caused by the impact, and just help to characterize the system and kind of confirm what it was that happened with this impact earlier on.
I'd be curious, because like, if you proposition the physicist to say, okay, there's this object that's this big, this other one that's this mass, because you know the mass of both, and they're traveling at this speed and they hit each other, you can tell me whether or not the velocity of the bigger one's going to be changed. But I guess one variable would be like the composition of the big one. We don't really know for sure, I guess.
Right.
But it just seems it seems like we kind of knew the result ahead of time, right? Like, isn't this a basic physics problem?
I think so. But I mean, the fact that we know it's going to happen, but like, do we have the ability to redirect an asteroid? Yeah.
Also, Didymos sounds like the base Pokemon, and Dimorphos sounds like the evolved version.
All right. Okay, let's move on.
Oh.
And finally, the Jupiter system. This is a lovely picture of Jupiter's volcanic moon Io from the Juno spacecraft. I don't know what's happening with Juno. Have you heard anything about its current status? Because its extended mission has come to an end, and it was very unclear whether there would be money to continue it with the current state of NASA's budget. It is still working, but I don't know if the extended mission is approved.
I think the approval needed to come through during the government shutdown, and now the government has reopened. I haven't heard any update on what's
No, I haven't. No.
I imagine, since the spacecraft is still mostly fully functional, that they'll manage to eke out funding to keep it going.
Yeah, I hope so. Yeah.
To shut down a functional mission. But this is crazy. I mean, I worked for the company that built GenoCam, like before it launched and like while it was on its way to Jupiter, and like that camera we thought would last for like 8 flybys of Jupiter.
Yeah, 8 orbits. Yeah.
And the fact that it still works is absolutely incredible. I mean, I had that job 20 years ago, almost 20 years ago.
Wow.
Yeah.
I know it feels weird.
You built it so well. No.
It's a hardy little guy.
It's all thanks to you, Tanya. Yeah, I mean, it is amazing that it has survived. It's not. It suffers quite badly from radiation, but they found a way to fix it between the flybys.
Tough environment out there in Jupiter land.
That's brutal. Yeah. So anyway, if we do get an extended mission, then over the next couple of years or so, they hope to make close flybys of some of the inner moons, which would be the little inner moons like Amalthea, which would be quite incredible to see. I've long dreamed of seeing Amalthea close up. Galileo didn't get a chance to do it. Actually, Galileo did make a close flyby of Amalthea, but its camera was knocked offline by the radiation.
I think this is your last slide, right?
Sorry?
I think this is your last slide.
Oh, it is, but let's just mention the bottom part of the text there. In the fall of 2026, 2 spacecraft that are on the way to Jupiter to look at Europa and the other moons, 2 spacecraft will both independently make gravity assist flybys of Earth, JUICE and Europa Clipper, and they're both going to loop past Earth and get a gravity assist that will push them to their final destination. So I only feel it's only right to mention that because it is happening in this coming year, and I might get a few pretty pictures out of it.
An encounter for Europa Clipper is
that's sort of about 29 or so, I think.
Yeah, something like that.
What are we going to talk about next year?
Everything
is just in cruise.
Yeah. All right. Yeah, so that is the last slide there.
I can find it. All right. Let's go to this view. All right. So anyone, you already mentioned Amalthea as something you're looking forward to. Is that your most looking forward to thing for 2026?
Yes, I don't know the exact date of any of these inner moon flybys.
Right, and it also depends, I guess, if there's any extended mission or what that extended mission looks like.
Yeah, and hopefully if the camera is still working, which hopefully it will be. Yeah.
Awesome.
Cool. So I mean, there's a lot of stuff happening next year.
There is. I feel like this is probably one of the bigger years we've had recently. I feel like 10 years ago, there was always tons of stuff, and then there was a little bit of a dip. I feel like after, Perseverance. I don't know.
It's good to be reminded that there's so much happening, because I think, especially as a Mars person, since there's nothing new really slated for Mars other than Escapade hanging out waiting to get there, you can kind of forget, there's nothing going on. No, there's a lot of stuff going on in other places, which is cool because Mars has more than enough data to keep people busy for decades. So maybe they can
say that. Don't say that.
I want more missions, to be clear, but it's good that other planetary bodies are going to get their day in the sun.
Yeah, that's right.
Mars needs like a Grail/Grace.
That'd be cool.
They need gravity map. That's my idea.
Yeah, high resolution gravity. That would be good. Yeah.
Kind of figure out that core business. I'm looking forward to the hopper. Any non-conventional rover movement is amazing.
Yeah, that's right.
They're crawling or hopping
I feel like personally the hopper is most exciting. I feel like professionally I have to want the Astrobotic mission to be successful. So fingers crossed there.
Right, of course, yes. Professionally and personally, we'll all be waving Canadian flags when Jeremy and yourself.
Oh, right. How could we?
Oh yeah.
That's terrible that none of us listed that as first. I'm very excited for Jeremy because it's Canada, and also just Jeremy's a good guy.
He's very nice.
Yeah.
Very nice. Yep.
Well deserving of being the first Canadian to the moon.
Mhm.
Or at least
We
around
will
the moon.
get to experience what Phil told us about him, and many other people told us about in our book. Just like watching a human mission to the moon, which I think I was talking to Phil about this in the past when I was visiting. Like, I've always watched it from the perspective of knowing what's going to happen, but and like looking at people or hearing their story about how either nerve-wracking or just like anxious and exciting it was. I'd be like, well, I don't relate because I've grown up always knowing they land on the moon, right? So it'll be interesting to experience actual uncertainty. Not that it's a good thing, but it'll be like, oh, this is like an attachment to the past in some way. Because
Yeah.
I never. I mean, you've watched missions you're involved with land, and I was excited and concerned about Perseverance and all these other missions, but it's different when there's people.
Totally.
Yeah.
Cool. All right. Well, thank you so much, Phil. I'm going to end the recording shortly. Yeah, we'll be back in another month or so with another episode of Space Club. Your monthly audiovisual learning broadcast. And until next time, we'll talk to you later.
Bye.
Okay. Bye bye.